of 12 days program on AI and data science tools for future generation learning. Today with us we have an eminent personality. So Dr. Kasar, founder and director, Aspire Research Center, Kuvempu Nagar, Mysore. Dr. Kasar, currently the director of Aspire Research Center, previously held the position of the Chief Research Officer at Robot Guru Education Technologies Private Limited between 21 and 23. He is also a consultant and a subject matter expert on AR and VR at AIARVR IIT Jodhpur. He played a pivotal role in nurturing collaborations between industry and academia, shaping curriculum strategies and course development, and pioneering the development of Holo World experiential 3D learning content for computer, mobile, AR and VR devices. He was the VP of Research at Kaya Incorporation during 2017 to 2021, where he worked on the development of Holo Suite, an AI-enabled full-body motion capture suite, post-analytics and teleoperation of humanoid robots. So, to talk about his education and qualification, he obtained MTech degree in signal processing from IIT Guwahati and PhD from IISc Bangalore. He was with the LITIS Lab, University of Rouen, France, and Doria Lab, University of Nancy, France, as a postdoctoral research fellow during 2012 to 2015. He actively engages with the academic community by conducting workshops and training programs on AR, VR, robotics, and AI in various engineering colleges, IITs, universities, and institutions abroad. I welcome you, sir, to this meeting. And also, I would like to introduce another resource person for today's session. Is Mr. Deepak MVS. Deepak MVS is an experienced technologist and educator over 15 years in robotics, engineering education, and industry collaboration. He is the chief growth architect at Aspire Research, an education technology company focused on pioneering innovations in IoT, augmented reality, virtual reality, and AI to transform the landscape of education and training. At Aspire, he leads strategic partnerships, technology sharing, and training initiatives. He has worked with global firms like HoloSuite, PTE Singapore, and has trained over 7,000 students in robotics and employability skills. A Cambridge certified trainer, CICTT UK, he has presented at international conferences, led faculty workshops, and conducted large-scale campus drives. Passionate about innovation, he is actively developing AI-enabled prototypes and educational robotic kits. He is also a tech blogger focusing on embodied AI, swarm robotics, and emerging technologies. Sir has done a CICTT University of Cambridge, UK. I welcome you to this session, sir. I hand over the session to the resource person. I request all of you to make the best utilization of today's resource.
There is no mic. I hope I am audible.
Yes, sir.
I'll try to come closer.
Mic is there.
Oh, the mic is there? Okay. That's better.
Hello.
thank you so much at the very outset. Thank you for having us here. We have come all the way from Mysore, and we are pleased to be a part of this FDP program. So today, I'll be talking on the intersection of AR/VR and AI. I think it's quite relevant for this theme. We will be looking at the various applications of AI, how AI has been booming over the years and how it is being used in the development of AR and VR. And we will look at new dimensions, new applications that is coming up out of this synergy between these three trio tech. So I'll mostly focus on, there are a lot of applications in diverse domains, but I'll try to focus on the learning or the training and skilling aspect. Yeah, so let me start off with this question. I hope you're all aware of this term metaverse. This was quite a buzzword a few years ago when Facebook rebranded themselves as Meta, I think around 2022, 21 or 22. And this has been actually going on for a long time, but only made popularized by Facebook. It was actually coined by American sci-fi writer Neil Stephenson in the year 1992. So in one of his novel called this Snow Crash, he talks about this metaverse, where metaverse represents a 3D interactive virtual environment where you can go into that virtual environment as avatars. You can meet other persons as in their avatars, and you can interact with them. So whatever we do in the real world could be done in that virtual simulated world. So this was just a concept at that point of time, and there was no technology to realize this vision at that point of time. But now, fast forward, Facebook have pumped in a lot of funding and research in making this vision a reality. Of course, we are still not there yet, but there's a lot of progress made over the recent years because of a lot of work going on in this domain. So, Metaverse talks about two worlds. Right? One is the real world that we live in, and the other is the virtual world. Now, it will be good to look at this nomenclature before we move on. This nomenclature, the virtuality continuum, was proposed by Milgram and Kishino in the year 1994. So around that time, they have clearly defined what is reality, what is virtual reality, and what comes in between. They have clubbed it as some kind of mixed reality. So there is a virtual reality, which is just the opposite of the real world. So on the other extreme, we have virtual reality. In between, we have, say, augmented reality, which is closer to reality, and augmented virtuality, closer to the virtual side. Let us try to understand a little bit of this terminology, then we can, I think, understand better. So let us see, in the real world that we live in, we are bound by these three parameters: time, space, and matter. We cannot teleport, right? We cannot teleport, we cannot do time travel, so we are all constrained by these parameters in the real world. In the case of virtual reality, all this concept of time, space, and matter does not exist like we actually observe in the real world. There you can have your own time scale. You can go back in time. You can pass through walls, right? You can be in any planet instantaneously. So all these are possible in VR. Let me just show a pictorial representation of what a virtual world will look like. Once you wear the VR headset, you are immersed inside the virtual environment, and you could be in some planet where there are multiple moons or multiple suns and so on. You could have landscapes like this where there is anti-gravity, for example. Everything is possible, right? More than this, if we look at educational aspect, for example, you can go inside the cell and you can see all the components of the cell, right? We can go inside the cell, we can go under the seabed, we can go inside the lava crater of a volcanic lava and so on. So many things that which is not possible in the real world is possible in this simulated virtual environment. Yeah. Before I move on, let me just touch upon these other terms also. So we have mixed reality in between these two extremes, and there are some different variations. Yeah. So if we remove the mass, so we don't have mass, we only have time and space. Okay. If we have only time and space without any mass, so the mass becomes virtual. So if you have a virtual object here, I can say it's augmented reality. If I have a virtual vase here, flower vase, right? In real life, it does not exist, but it is blended with the geometry of the real world. So let me just show you in the form of an example. Yeah, so, sorry, the previous one. So here you can see you have a business card, and on that business card or the product card, you get all the information. So all these displays are virtual. It does not exist, does not have any mass, but it is registered with your card that you hold. So wherever it moves, and it is also in sync with the time. So time space is there, but no mass. So this is the a pictorial representation of augmented reality. So augmented reality, the virtual objects get blended with your real world environment. Let me just move on and even explain this also, because so before, in the time of Milgram and Kishino in 1994, they have a very loose term called mixed reality, but nowadays, because of the advancement in the devices, the hardware, there are some dedicated hardware only for mixed reality. And when we talk about mixed reality nowadays, it means the same augmented reality. It is augmented reality, but it is observed through a wearable device. So normally augmented reality will be consumed on a phone screen or a tablet screen. So when you view through a phone or a tablet, you will see the virtual content. But here, you are going to see the hologram in 3D. So the difference between augmented reality and virtual reality is that in the case of, augmented and mixed. In the case of mixed reality, you are able to walk around and interact with the object in 3D. So instead of seeing only on the screen. So in augmented reality, interaction is 2D. In mixed reality, it is 3D. So you can go and see what is behind the table and so on. In AR, it is not possible. So this is about the terminology. Let me move on to the actual details and working of this VR technology. We'll also look at the technology behind AR also, and we will try to look at some applications, how different industries are utilizing this immersive tech. So let me start with virtual reality. Once you have a virtual headset, once you wear a virtual headset, you'll be immersed in a virtual environment, and basically the headset is rendering a simulated environment, and your field of view is blocked. So you will be actually seeing a virtual environment. Inside the headset, the display is something like this. You have one left eye display and one for the right eye. So the images are a little distorted. It's not a rectangular image, right? There is a deliberate reason behind doing this. So the rendering of the image on each screen in front of the headset is barrel distorted. So this is a barrel distortion. This is done because in order to get a large field of view, this distortion is done. I will explain in the subsequent slides. But before we move there, we also need to, once we wear the VR headset, we also need to demarcate some boundary as a safe place to experience the VR. Otherwise, we end up hitting the table and we get hurt. So for VR experience, I think this area could be a good place to experience it. So we will mark the boundaries, and we also have the controllers in our hand, which will help us pick up objects and interact with the virtual environment. So this constitutes the ecosystem of the virtual reality setup. There are different versions before, but this version now is becoming very, very popular. It's a completely standalone headset without any other requirement. You can just use or experience VR anywhere. So now we will see why the image was distorted. Now here, our eye is here, and the screen, if you look at the VR headset, can we just remove the VR headset? It's inside. So our screen is just right in front of us. It's just about 2 or 3 centimeters in front of us, and the field of view is very, very narrow. So we cannot see a wide field of view once we wear the VR headset. So what this was invented by a young boy called Parmal Lucky, 19 years old. He invented this low-cost version. Before it was very, very big, very bulky, and very expensive also. But what he has, only the small, the other one. So he has put a lens here. So by putting the lens, the field of view expands beyond. So most of these headsets currently, they have 110 degrees field of view, and because of which you get an immersive feeling. Otherwise, you'll be seeing through a small narrow hole, and we don't feel immersive or real, right? Viewing that small field of view. So here you can see in the VR headset, you have 2 lenses, one for the left eye, one for the right eye, and just in front of them is a screen. So there's one screen for the left eye, one for the right eye. So again, this is a little different from the normal image processing that we do. We process one image as a whole, but here there's one image for the left, one image for the right. So there is also a lot of design issues coming when you are designing UI menus and all. Most of the screen size is defined, but here there is no screen size. So there is one for the left, one for the right. Let me just explain why we do this. I hope we all know the lens is increasing the field of view, and as it increases the field of view, it also introduces distortion because of the spherical lens it has. So now to undo this, so if you have a normal image, if it is viewed with a lens, the distortion is the pincushion effect. So you have this kind of pincushion effect, and what that young boy, 19-year-old boy, he has done this way of rendering. So parallel distorted rendering on the LCD screen, and the lens is giving the inverse of that. So the effect is that for the user, they will see the undistorted white field of view image. So this is the trick that he has done, and because of which the headset has now become very, very small, very compact, and it's affordable. So this is done by Palmer Lucky, founder of Oculus, and that is the first time this VR headsets have come to the consumer level. Before it was only in big industries and defense, US defense, where they were only using it. But because of this simple trick, so what he has done this distortion of the image using a simple software, and then in the hardware he put the lens, and then he's able to make it very compact, lightweight, and also at the same time affordable. Now you can just see pictorially how it is here. We have the parallel distorted image. You see through your headset lens, and you can see this kind of very wide field of view image, and you feel like you are in that environment. Now this gives us much more immersion, right? And this is one good feature of VR. So VR has to be as real as possible. Otherwise, we will not feel good being there inside a virtual environment. So this is one factor. There is, coming to the technology, behind this, there are different ways of detecting your head. So when you wear it, as you move around, your headset position or the user's position should be detected. Now before there was a system like this where they have trackers or base stations mounted on the corners of the ceiling, and they will be flooding this sweeps of this IR rays, and this will be having the receiver transmitter there, and they will detect the position. So now those are actually very accurate, but the problem is that it has to be set up and it is very difficult to take it to another location for demos. But we have this kind of tracking right now. It's all based on your image understanding, based on computer vision. The headset has outward looking cameras. So here there are 4 of them, one here, and in front also there is one. So here there are totally 5. But if you look at the Apple Vision Pro, I think there are 18 cameras. So basically, it is able to understand the entire scene around us. So this headset, it is seeing the scene, and based on feature matching, feature extraction, feature matching, it is even if it is moved, it knows that it is the same feature that is redetecting. So based on this, we have inside this headset, there is this algorithm called SLAM, simultaneous localization and mapping. Again, this is a very fundamental algorithm which is even used in autonomous robot navigation also. So in robot navigation, the robot is able to navigate in an unknown environment based on this SLAM algorithm, but they will be using some kind of ranging, some distance sensing rays, but here it is based on visual features. So based on this image features, we will be able to estimate the position of the headset in real time. And also, it comes with these 2 controllers, one for the left hand, one for the right hand, and this has again the IR transmitter receiver, and it is already paired with the headset. So the headset knows where your left hand is, where your right hand is. So together you can use it to interact with the virtual environment. So this is a brief overview of the VR working or principle of the VR. Mostly in pictorially I have explained without going into the details. So these terms are used the outside in tracking, like you have the trackers outside and you're looking inwards. This is inside out. So from the headset, you're looking outwards and trying to understand the surrounding around you. And most of the headsets nowadays is using this inside out tracking nowadays, because this gives them full mobility. And in the previous ones, normally this is tied with a cable to the PC, and the trackers are put in the ceiling, and it can be used only in this room, right? You cannot take it to another room. Again, you have to set it up in another room. So it takes a lot of time. But it was very accurate. But nowadays, because of the advancement of AI, image processing algorithms, the depth sensing, including all this, there is no depth sensor here, but there are new headsets with very accurate depth sensors. So once you wear it, it knows each and every object in this room. It knows the height of this table, the floor. So if you roll a ball, virtual ball, it will roll on the table surface and it will fall off. So it understands that there is a depth. If you throw a ball, it will bounce back by hitting the wall. So you have this physical and virtual objects interacting with each other seamlessly. And that is possible because of the advancement in the scene understanding. Basically, because of the advancement in AI, all of these are possible now. Now let me talk a little bit about AI. So coming to augmented reality, I will show some demos towards the end also. So augmented reality, is consumed on a 2D screen. So you have your smartphone, or it could be a tablet, and you point onto any image or any object or even face. There are face filters, right? Lenskart is using face filters to try different classes. And similarly here in this particular example, the user is pointing the phone or this tablet onto some device. Now this device gets augmented here with additional instructions. So how to repair it, how to troubleshoot it, for example. So all these instructions can be given here. The only thing is that this system should recognize this model. So it could be a car engine. When you open the bonnet and when you point your phone onto the engine, if you can troubleshoot it, right? So all these things are possible with the help of this AR guided augmented instruction. So it could be some instruction to connect some wires or to remove some plug or whatever. So all those things can be taught. So in fact, there are so many use cases like this. I think it was G that had come to us. We did some industrial training procedure for this kind of application. I think it consisted more than 360 steps. So to build all those steps, it takes a lot of time, but once it is built, they use it to train new employees, new workers who join the company before they actually go to the actual device. They are already accustomed to it. They already know, at least virtually, how it works, how they have to follow the standard operating procedures. So many of those things can be done in this domain. John Deere for tractor. Yeah. So like equipments, like heavy equipments like tractor and all, it's very difficult to teach. You have to put the implements for agriculture, and we did a lot of simulations like that, where we have virtual tractor. We show them how to implement that hitching process. They can attach any kind of tools, and then you can drive around. You can do the blowing and all those activity in the virtual setting. So that was there's a lot of use case in the industry. Let me explain the principle of this augmented reality. Again, it's image processing. So our smartphones have a camera. Camera is one of the very important sensor in augmented reality. It will be looking at the scene around us. Here in this case, I'm using a simple marker, and this marker, once we segment it, we remove the background, we identify the foreground, and if we are able to get the position and orientation. So we need two information in AR. Where is this marker and what is its orientation? So this information is encoded in this pattern. So once you recognize this pattern, you can find out the orientation and position of that particular object. Sorry, because I touched it, I guess.
No, I think
I should not touch it.
no, you can, sir.
Okay. So, in augmented reality, only 6 parameters we need. Position in X, Y, Z, rotation X, Y, Z. So, position and orientation, once we have it, then we can embed any virtual object in this position with that orientation. So that when we move this marker, the virtual object moves along with it. So it's already registered with respect to this particular geometry of the marker. And then you can see that virtual object superimposed or overlaid on the marker. So this is a very simple AR where image is used as a trigger to bring this virtual content.
So it's both image processing and graphics.
Yes, graphics in the sense we need to have the 3D models built in advance. So I have some demos I'll show you. I'll put a virtual robot here and all of us can take a selfie. Okay, so we have got that virtual robot built by some 3D artist. So when we actually build applications, yes, we need a team of 3D artists we need a game developer, a computer programmer, and a designer for making the app